This is Jill Scott, and today we're going to be talking about encouraging an early interest in STEM. This project is a part of my qualifying exams, and it's a presentation to go over my niche, my literature review, and my qualifying project that I've completed in requirements for the qualifying exams for the University of Florida EDD Educational Technology Doctorate. To better understand my niche, I thought I would share with you a bit about my background. I've always been a science enthusiast, a naturalist, and a collector. I grew up with a father who was a math professor, an uncle a zoology professor. I grew up attending a science center here in Florida as a student and a counselor. I studied science all through high school and decided to study zoology at the University of Florida. I received my Bachelor of Science in Zoology from UF in 1980 and went on to get my Master of Science Education at the University of Florida, which I received in 1982. At that time, I became a high school science teacher and taught for 8 years in Gainesville, also in Boston, Massachusetts, and in New York City. In 1982, I came to Orlando, Florida, and began teaching at Lake Highland Preparatory School, an independent pre-K to 12 school in downtown Orlando. I've spent my past 20 years teaching science to children in grades pre-K to 6. It was at Lake Highland I began to find my true niche as a science teacher, that is to inspire students to love science. I've learned to see science through the eyes of children. In my professional practice at Lake Highland Preparatory School, I'm the science enrichment teacher for students in grades 3 to 6. I serve as a faculty leader and the science subject coordinator. In 2004, I received my gifted endorsement from the state of Florida, and in 2008, I received my educational specialist in curriculum instruction from the University of Florida. This year, I became the coordinator of science education for grades pre-K to 6, and I work with all the teachers of science in pre-K to 6. Three years ago, I also began an after-school club for girls interested in science and STEM, known as Einstein Girls. Research shows that girls succeed when in groups with other girls. The Einstein Girls program utilizes the informal science learning model and utilizes inquiry-based learning, community building, and career exploration. The Einstein Girls program gave me the inspiration for my literature review and actually became the subject of my qualifying project. My research framework for my literature review and my qualifying project is as follows. I believe in inquiry-based science experiences for all learners in grades pre-K to 6. I also have decided to focus specifically on pre-adolescent girls in grades 5 and 6. In all my teaching, I involve students in social learning groups, within grades or between grades. And the conceptual framework of social constructivism informs all of my work. My literature review focuses on women and girls in STEM. First, I look at the current status of women and girls in STEM, and then I selected 3 strategies to encourage an interest for girls in STEM. STEM stands for science, technology, engineering, and mathematics. In my literature review, I looked at STEM occupations, women in STEM occupations, STEM majors available in college, and what women were taking and what they were majoring in college. I found there's a shortage of STEM-trained workers in the United States and that we've come to rely on imported talent. I also found that women are underrepresented in STEM jobs. Since the pathway to a STEM career is often a STEM degree in college, found that women were underrepresented in some of the STEM areas in college. Girls are more likely to choose courses and careers in STEM if their interests in these fields are ignited and cultivated during their K-12 school years. K-12 STEM education should incorporate strategies to generate an interest in science for girls. Research tells me that these interests should be encouraged as early as possible, preferably before the middle school age. There are many research-based strategies suggested that encourage an interest for girls in science. For my literature review, I selected 3 strategies. The first one is informal science learning. The second strategy is mentoring. And the third strategy is the use of online learning communities. Informal science learning is defined as science learning outside the traditional setting and may utilize after-school academies, summer camps, clubs, off-site field trips, science museums, etc. Informal science learning utilizes the best practices of inquiry-based learning, problem-solving, collaboration with peers, working with experts, mentoring, and career exploration. The constructivist view of learning may inform the research and the interpretation of research on informal science learning. There have been many successful informal science learning groups for girls that are already in place. I created the Einstein Girls and used the successful ISLs as a pattern for my Einstein Girls. Mentoring refers to a relationship between a more experienced person and a novice. The theoretical grounding for mentoring, while not well defined, is often included under the broader category of learning theories, specifically cognitive apprenticeship, constructivist, and socio-cultural theories. Cognitive apprenticeship provides a theoretical framework for the process of helping novices become experts through one-on-one guidance and is grounded in mentoring, coaching, and modeling. A mentoring relationship may provide a girl a spark for interest in STEM, and there are several successful mentoring programs already in existence. The third strategy outlined in the literature review is that of online learning communities. A learning community is a group of individuals who interact with each other and build relationships with each other, and in doing so create a feeling of belonging and commitment among the members. A learning community may be face-to-face or it may be online. Learning communities have a theoretical framework in social constructivism. New Web 2.0 tools offer the opportunities for communities to be built outside the borders of a traditional face-to-face group. My literature review informed my qualifying project. My qualifying project is called Einstein Girls: Growing an Interest in STEM, and it's a program evaluation. My 3 program evaluation questions were: number 1, in what ways, if any, does the Einstein Girls program allow girls to work in cohorts with those of similar interest? Number 2, in what ways, if any, does the Einstein Girls program engage participants in inquiry-based, real-world STEM activities? And number 3, in what ways, if any, does the Einstein Girls program inform participants about careers in STEM? The first part of a good program evaluation would include a program description to help the reader understand the nature of the program. In my program description, I talked about Lake Highland Preparatory School, gave it a description, the after-school academy, how it was run, who runs it, and some of the demographics of it, specifics about the Einstein Girls Academy, who the participants of the Einstein Girls Academy were. They are 5th and 6th grade girls. It's a voluntary academy that is paid for by parent funding. The activities and components of the academy, and the resources that we utilize to make the Academy successful. For the program evaluation portion, I used the research framework of quantitative data and action research in a mixed methods approach. My sample included 23 current Einstein Girls participants. I collected data in several ways. Qualitative data was collected from my participants through their journals and their online writing prompts accomplished in our Moodle course. Quantitative data was collected from the girls using Likert scale questions. Field notes were used by me to record information and observations of our group. And then quantitative data was collected from all 6 Einstein groups for descriptive purposes. My data analysis utilized writing prompts which revealed how participants felt about various aspects of the program. The Likert scale questions allowed the participants to express their answers to questions and specify levels of agreement or disagreement in a symmetrical fashion. The field notes I took captured the nuances that took place during our meetings, and the descriptive data described the trends and patterns of all 6 groups over time. A careful analysis of the data revealed the following information. Number 1, the participants are becoming a cohort of girls who share similar interests. Many of the girls answered questions in regards to friendships, new friends, and being with friends. The girls had in common an interest in science, and the increasing enrollment of the Academy over 6 semesters shows an interest in science and a cohort nature of the group. Number 2, the participants were involved and are involved in inquiry-based real-world STEM activities. An analysis did reveal a shortage of engineering topics, so for this semester we spent virtually the entire Einstein Girls Academy studying engineering. The participants are also learning about STEM careers. Over the course of 6 Einstein Girl Academies, we studied 34 careers and we used 10 guest speakers. This semester we had 2 guest speakers and we took numerous lab visits. The cohort nature of the Einstein Girls was revealed by the common themes of interest, fun, and friendship. Participants indicated an interest in science, and the enrollment of the group has increased steadily over the past 6 semesters. The Academy offerings data also indicate a steady improvement in offerings based on what was learned in previous semesters. And the girls were informed about many careers in STEM and specifically about careers and opportunities available to them in engineering. My program evaluation revealed the following implications. You should provide opportunities for girls to work in groups with others who share an interest in STEM. Start the outreach as early as possible in their schooling years. Whenever possible, utilize inquiry-based, real-world STEM activities during informal science learning meetings. Use technology tools available to make the activities more engaging and relevant. Begin teaching girls early about career opportunities in STEM and encourage them to continue in their studies of STEM. Expose them to role models who are currently employed in STEM and encourage ongoing relationships between the girls and role models. These are the conclusions after completing my program evaluation. The Einstein Girls program has been a success at bringing girls together to learn about STEM. The girls were most engaged when doing inquiry-based STEM activities and using technology tools. The girls appreciated the focus on STEM careers and enjoyed the contact with female scientists. This program and similar programs are well positioned to encourage continued interest in STEM and STEM careers for girls.